This is UTexas, Newton Extra, number 8 and 9. First off, I'm going to start off with number 8. Consider the 656 Newton weight held by two cables shown below. The left-hand cable has tension T and makes an angle with the wall. The right-angle cable has tension 710 newtons and makes an angle of 32 degrees with the ceiling. What is the tension T in the left-handed cable slanted at an angle of degrees with respect to the wall? Answer in units of newtons. Okay, first off, we're going to start off every time an equation contains the word equilibrium, you have to put the f net of x equals 0 and f net of y equals 0. Which then in this case we'll have this is how it has to look like. And the next step is we put f net of x equals f1 of x minus f2 of x, because we're trying to find the right side with the angle of 32 with the 710 newtons, because that's the side that we can find first, and then we can solve for the other side. And then we just add the f2 of x to the other side, and then it'll come out to f of 1x equals f of 2x, pretty much. Okay, let's start this. Okay, now we need to solve in. We're going to have to use the SOHCAHTOA for the triangle. And in this case, we have the adjacent and the hypotenuse. And then all we pretty much do, we get the angle alone, the side alone, and then you should come out with your numbers. Well, with my numbers, I have 710 cosine 32 degrees. And then you plug it all in with the calculator and make sure your calculator is in degree mode and not in radian mode, because you get a way smaller number than you should. And my answer, I got 602.11. Okay, now we do it for the other side, since we have the other side of the triangle, because we're trying to find the whole big triangle, but we broke it in half. This time with this equation, if f2 of y equals fg, gravity, minus f1 of y. And then all we have to do is do f2 of y, and then we just solve all for that. And then it basically equals with my weight is 656, so then we use the weight 656. Sorry about that, 656. Then you subtract, and in this case, SOHCAHTOA, we're using sine, which is opposite over hypotenuse, minus 710, which is your newtons on the right side, sine of your angle, 32. And you should come out with a similar number, or a number around 279.75. And now all we just do is the easy step, which is a squared plus b squared equals c squared. So then for our other side, we got 602.11 squared plus 279.75 squared. Is our c squared? Oh, give me a second. So then I'm gonna rewrite this so you guys can get a better reading. 602.11, another one squared plus 279.75 squared equals c squared. Then we add all that up, and then we find the square root. I got for mine 663.93 newtons, and that's your number 8. Now number 9, it asks for what is the angle of theta with the left-hand cable makes with respect to the wall. Answer units of degrees. Now this is all we gotta do is we use the tan of theta, or x, whatever how you like it, of 602. TOA is opposite over adjacent, 0.11 over your 279.75. We solve for that, so then we use the inverse tan of what you got from there, which then that would be 602.11 over 279.75. And then it should come out to an angle. And yeah, make sure this is in degree mode. I came out with an angle of 65.08 degrees. And that's it.